In a remarkable achievement for North Carolina agricultural education, 2 journalism students from North Carolina A&T State University have been selected for the prestigious MIT HBCU Science Journalism Fellowship. This fellowship, aimed at enhancing the representation of historically black colleges and universities' HBCUs in science journalism, offers a unique opportunity for the selected students to engage with experts and gain invaluable skills in reporting on scientific topics. Their selection underscores the growing recognition of diverse voices in the field of science journalism, a sector that has often lacked representation from minority communities. This fellowship comes at a crucial time when the intersection of science and communication is more important than ever. As the world grapples with complex issues such as climate change, public health crises, and technological advancements, the demand for well-informed, accurate, and engaging science journalism is paramount. The students' participation in this program is expected to not only enhance their personal and professional growth but also contribute to a broader understanding of science in communities that have historically been underrepresented in these narratives. The initiative is part of a larger movement to ensure that voices from diverse backgrounds are included in conversations about science and technology, thereby enriching public discourse. As the fellows embark on this journey, they will have the chance to learn from top journalists and scientists, equipping them with the tools needed to effectively communicate complex scientific information to varied audiences. In addition to this inspiring news from North Carolina A&T, advancements in soil health monitoring and research are also making waves in the scientific community. A recent article published in Reviews of Geophysics highlights innovative methods for assessing soil health, emphasizing the crucial role that healthy soils play in sustaining life on Earth. Healthy soils are not only pivotal for agricultural productivity but are also essential for clean water, climate regulation, and overall ecosystem health. The research explores how digital twins and satellite-enabled technologies are revolutionizing the way scientists monitor soil conditions. These tools allow for a more comprehensive understanding of soil health by linking physical, chemical, and biological properties to soil functions across different scales. Despite these advancements, the authors of the study note that significant gaps remain in understanding the complex interactions within soil ecosystems, particularly concerning microbial communities and their role in nutrient cycling. As nations worldwide continue to face challenges related to food security and climate change, the findings underscore the urgency of addressing soil health. The ability to monitor and predict changes in soil conditions can inform better land management practices, which are essential for fostering sustainable agricultural systems. Meanwhile, a separate study has shed light on the geological phenomenon occurring under South Africa, revealing that the land is rising due to ongoing drought conditions. Researchers utilized GPS data to show that South Africa's land has risen an average of 6 mm between 2012 and 2020, primarily due to decreasing water levels in reservoirs and groundwater. This surprising correlation between drought and land uplift suggests that the region's geological stability may be more influenced by water loss than previously thought. As scientific research continues to unveil the intricate connections between environmental conditions and geological changes, it becomes increasingly important to incorporate these findings into policy and management strategies. The combined insights from soil health monitoring and geological studies indicate a pressing need for interdisciplinary collaboration to address the multifaceted challenges posed by climate change and environmental degradation. In conclusion, the selection of North Carolina A&T students for the MIT HBCU Science Journalism Fellowship and the ongoing advancements in science communication signify a positive shift towards inclusivity and representation in the field. At the same time, the research on soil health and geological uplift highlights the critical importance of understanding our environment as we move forward. These developments not only enhance our knowledge of the world around us but also pave the way for future innovations in science journalism and environmental management. As we continue to explore these vital areas, it is clear that the intersection of science, technology, and communication will play a pivotal role in shaping our collective future. In a significant turn of events impacting the future of pandemic preparedness, the U.S. Department of Health and Human Services (HHS) has canceled a substantial $766 million contract with Moderna, Incorporated. This decision effectively halts funding for the development of an avian influenza vaccine H5N1 using mRNA technology, a method that has gained prominence due to its success in combating COVID-19. This cancellation raises critical questions about the direction of vaccine research and the role of mRNA technology in addressing emerging health threats. The contract, initially awarded to Moderna through the Biomedical Advanced Research and Development Authority (BARDA) in 2024, was designed to bolster the nation's capacity to respond to potential pandemic outbreaks. However, following a recent review, HHS concluded that further investment in Moderna's H5N1 vaccine was not scientifically or ethically justifiable. HHS Communications Director Andrew Nixon stated, "The reality is that mRNA technology remains undertested, and we are not going to spend taxpayer dollars repeating the mistakes of the last administration, which concealed legitimate safety concerns from the public." Despite this setback, Moderna has reported promising interim results from its Phase 1 of 2 clinical trial of mRNA 1018, the H5 avian influenza vaccine. Involving 300 healthy adults, the study found that nearly 98% of participants achieved protective antibody levels 3 weeks after the second dose, with antibody titers increasing over 44-fold from baseline. The vaccine exhibited a generally favorable safety profile, with side effects predominantly mild to moderate and no serious safety concerns raised. Moderna CEO Stephen Bancel expressed disappointment over the funding cut but emphasized the company's commitment to exploring alternative strategies for advancing the vaccine. He noted, "While the termination of funding from HHS adds uncertainty, we are pleased by the robust immune response and safety profile observed in this interim analysis. These clinical data underscore the critical role mRNA technology has played as a countermeasure to emerging health threats." Additional study results are expected to be presented at an upcoming scientific conference, offering a deeper insight into the vaccine's potential. The cancellation comes amid a broader discourse surrounding the efficacy of mRNA vaccines, particularly from figures like Health Secretary Robert F. Kennedy Jr., who has publicly questioned their value. Recent announcements by the CDC, which have removed COVID-19 vaccines from the recommended immunization schedule for healthy children and pregnant women, have further fueled this debate. As the landscape of vaccine development continues to evolve, the implications of this funding withdrawal may resonate throughout the industry. Should Moderna navigate these challenges successfully, the ongoing development of mRNA vaccines could still play a pivotal role in future pandemic responses. However, as the company seeks new avenues for funding and research, the immediate future of its H5N1 vaccine remains uncertain. The response of the scientific community and public health policymakers will be crucial in determining how mRNA technology is integrated into the fabric of pandemic preparedness strategies moving forward. In an era where cancer research is at the forefront of medical innovation, significant strides are being made to tackle some of the most challenging forms of the disease. Recent developments from esteemed institutions like Mount Sinai and Weill Cornell Medicine highlight a commitment to advancing our understanding and treatment of cancer, particularly ovarian cancer and late-stage stomach cancer. These efforts underscore the essential role of interdisciplinary collaboration and innovative funding models in the fight against cancer. At the 2025 American Society of Clinical Oncology ASCO conference, Mount Sinai showcased its pioneering research initiatives aimed at transforming cancer care. As one of the leading medical centers, Mount Sinai's participation underscores its dedication to not only advancing treatment protocols but also improving patient outcomes through cutting-edge scientific inquiry. The conference serves as a platform for experts to discuss new findings and share innovative approaches that could redefine cancer treatment paradigms. Simultaneously, while Cornell Medicine announced that Dr. Juan R. Cubillos-Ruiz and Dr. David Leiden are the inaugural recipients of the Pershing Square Foundation's Ovarian Cancer Challenge Grant. This prestigious grant, amounting to $750,000 over 3 years, is designed to support innovative research into ovarian cancer, a disease that claims nearly 13,000 lives annually in the United States alone. Dr. Cubillos-Ruiz, a distinguished expert in immunology, emphasized the importance of this funding in a landscape where federal support for ovarian cancer research has dwindled. This award comes at a crucial time, he stated, highlighting the urgent need for resources dedicated to the study of aggressive cancers that often receive insufficient attention. Dr. Cubillos-Ruiz's team plans to explore a previously overlooked population of immune cells in the peritoneal cavity, the site where ovarian cancer frequently spreads. Their research aims to harness these immune cells to develop long-lasting protective immunity against ovarian cancer, potentially leading to more effective treatment options. Dr. Leiden's research, on the other hand, focuses on utilizing tumor cell-derived extracellular vesicles as biomarkers for early detection of ovarian cancer and predicting its metastatic risk. There is an unmet clinical need to study ovarian cancer metastases and its early stages, Dr. Leiden noted, emphasizing the critical nature of their work in improving early diagnosis and targeting metastasis. In another breakthrough, scientists in Dallas are developing a light-activated treatment for late-stage stomach cancer, showcasing the diverse approaches being taken in cancer research. This innovative method could potentially offer a new avenue for patients facing limited treatment options in advanced stages of the disease. By harnessing light to activate therapeutic agents directly at the tumor site, researchers aim to enhance treatment efficacy while minimizing collateral damage to healthy tissues. The convergence of these research efforts illustrates a dynamic landscape in cancer treatment characterized by a blend of innovative funding, groundbreaking scientific inquiry, and a commitment to improving patient care. As institutions like Mount Sinai and Weill Cornell Medicine continue to push the boundaries of cancer research, the potential for transformative therapies becomes increasingly tangible. Looking ahead, the collaboration between philanthropic organizations and research institutions will be paramount in sustaining the momentum of these advancements. With a focus on early detection, innovative treatments, and improved patient outcomes, the future of cancer research holds promise for those affected by this pervasive disease. As funding supports the ongoing exploration of new therapeutic avenues, the hope remains that the battle against cancer will yield more victories in the years to come. In an era where artificial intelligence is reshaping industries, a significant breakthrough has emerged from a collaboration between the University's Space Research Association USRA, the Boston Consulting Group's BCG AI Science Institute, and NASA. On May 29, 2025, these organizations announced the open-source release of the GAIA Geospatial Artificial Intelligence for Atmospheres Foundation model, a pioneering tool designed to predict and analyze extreme weather events. This innovative model aims to address one of the most pressing challenges of our time: the increasing frequency and intensity of natural disasters, which have seen costs escalate more than 100-fold over the past 2 decades. The GAIA model has been trained on an extensive dataset spanning 25 years, utilizing information from various weather satellites, including the Geostationary Operational Environmental Satellites GOES, European Mediasat EUMETSAT, and the Japanese Himawari. The initial applications of this model focus on filling gaps in satellite data and enhancing the tracking and forecasting of extreme phenomena such as tropical cyclones and atmospheric rivers. We have moved beyond traditional task-specific machine learning models, which require separate models for each weather event, to a single global foundation model, explained Dr. David Bell, director of USRA's Research Institute for Advanced Computer Science. This collaborative effort is part of USRA's broader initiative to leverage generative artificial intelligence for scientific and engineering applications. The GAIA model embodies a significant advancement in geospatial AI, balancing attention across local and global features and weather data, an essential capability as climate change continues to challenge our disaster preparedness and response systems. The Gaia's foundational model for the planet places our Gen AI lab at the forefront of the upcoming AI race for space intelligence, added Dr. Olivier Ryman, co-founder of the Gen AI Lab for Science and Engineering. The launch of GAIA also reflects a commitment to open science, with the foundation models readily available on Hugging Face, promoting shared knowledge and collaborative progress in the field. Dr. El-Sayed Talat, president and CEO of USRA, highlighted the importance of this initiative. This new collaboration goes beyond existing foundation model research and takes it a step further into tracking and forecasting extreme weather applications. As the frequency of extreme weather events continues to rise, the implications of such advancements are profound. The integration of AI and weather forecasting not only enhances our understanding of atmospheric phenomena but also improves our ability to mitigate the impacts of disasters on communities. With the economic toll of natural disasters now reaching tens of billions annually, the need for innovative predictive models has never been more urgent. Looking forward, the partnership between USRA, BCGX, and NASA sets a precedent for future collaborations in the realm of artificial intelligence and earth sciences. As technology evolves, the potential for AI to transform our approach to climate resilience and disaster management is immense. The GAIA model represents just the beginning of what could be a new era of data-driven solutions aimed at safeguarding our planet and its inhabitants against the escalating threats posed by climate change. In a groundbreaking development for clean energy, scientists are racing against time to harness the power of nuclear fusion, a process that has long been regarded as the ultimate solution to humanity's energy woes. With efforts underway in both China and the United States, the pursuit of a working fusion reactor is no longer a distant dream but a tangible goal within reach. Recently, Chinese scientists achieved a significant milestone with their experimental nuclear reactor known as the Experimental Advanced Superconducting Tokamak East, often dubbed the Artificial Sunday. This reactor successfully maintained a steady-state high-confinement plasma operation for an impressive 1,066 seconds, surpassing its previous record of 403 seconds. The achievement is a crucial step toward realizing a functional reactor capable of continuous power generation, as it demonstrates the potential for sustained nuclear fusion, which could provide a virtually limitless source of clean energy without the harmful emissions associated with fossil fuels or the long-lived radioactive waste from traditional nuclear fission. Song Yuntao, vice president at the Hefei Institutes of Physical Science, emphasized the importance of this breakthrough, stating, "The duration of 1,066 seconds is a critical advancement in fusion research. This long-duration operation was made possible by significant upgrades to the East reactor, including doubling the power output of its heating system, which now operates with the equivalent power of approximately 70,000 household microwave ovens." These findings offer invaluable insights for global fusion development and underscore the growing momentum in this field. Meanwhile, in the United States, a parallel effort is taking shape with the Commonwealth Fusion Systems Spark reactor situated just outside Boston. This project aims to create a fusion power plant by the early 2030s. Backed by more than $2 billion in private investment, Spark utilizes first-of-its-kind magnet technology to achieve nuclear fusion by fusing atomic nuclei similar to the processes occurring in the Sun. If successful, Spark could represent a monumental breakthrough in achieving net energy, where a fusion reactor produces more energy than it consumes. Virginia Governor Glenn Youngkin highlighted the urgency of this endeavor at a recent energy conference, asserting, "There's a race to lead the world in power generation." Fusion energy promises to deliver a safe and reliable alternative to traditional energy sources, utilizing deuterium found in seawater and tritium sourced from lithium, which are far cleaner than fossil fuels. Experts believe that the advancements in Spark's magnet technology could accelerate the global development of fusion energy. Unlike solar and wind energy, which are dependent on weather conditions, fusion offers a stable and continuous energy source. Moreover, the safety profile of fusion energy is compelling. As Commonwealth's Chief Science Officer Brandon Sorbum noted, "If you were to blow a breath of air onto the plasma, you would kill it," implying that any malfunction would not result in a catastrophic failure. China and the US are not the only players in this high-stakes energy race. The International Thermonuclear Experimental Reactor ITER project in France, which aims to become the world's largest nuclear fusion reactor, has also faced delays but remains a critical part of global fusion efforts. With China contributing around 9% to ITER's construction and operation, collaboration across nations may become increasingly important in the pursuit of sustainable energy solutions. As these endeavors continue to evolve, the potential implications for energy production, environmental sustainability, and global cooperation are immense. The successes of Easton Spark mark not just technological milestones but a shift towards a future where clean, limitless energy might finally be feasible. Scientists and researchers are optimistic that with continued investment and innovation, the dream of nuclear fusion could soon become a reality, transforming the energy landscape for generations to come. In a groundbreaking revelation, physicists at MIT have discovered a new class of superconductor that exhibits both the ability to conduct electricity without resistance and intrinsic magnetic properties. This discovery, which emerged from research led by a team involving Assistant Professor Long Zhu, was published in the journal Nature and has profound implications for our understanding of superconductivity and potential applications in advanced quantum technologies. Traditionally, superconductors are characterized by two defining features: zero electrical resistance and the expulsion of magnetic fields, known as the Meissner effect. These properties have made superconductors essential in technologies like magnetic levitation, maglev trains. However, the MIT team's findings challenge long-standing assumptions about the relationship between superconductivity and magnetism. They isolated microscopic flakes of a material made from graphite, a common substance found in pencil lead, and observed that under certain conditions, specifically when stacked in a rhombohedral configuration, these flakes exhibited superconductivity at temperatures close to absolute zero. The researchers found that these flakes, when subjected to an external magnetic field, could switch between two distinct superconducting states, akin to how a magnet might flip its orientation. The general lore is that superconductors do not like magnetic fields, Zhu explained. But we believe this is the first observation of a superconductor that behaves as a magnet with such direct and simple evidence. This counterintuitive behavior suggests that the material may possess a type of internal magnetism, a property not previously associated with superconductors. The implications of this discovery extend beyond theoretical interest. The unique chiral superconductor, as described by the researchers, may offer new pathways for the development of topological superconductors, which are critically important for fault-tolerant quantum computing. It's one of a kind, noted Tonghang Han, a fifth-year student involved in the study. This is the first observation of a superconductor that behaves as a magnet due to the electron's orbital motion. Meanwhile, Zhenglu Li, an assistant professor at USC Viterbi School of Engineering, has been honored with a prestigious National Science Foundation NSF Career Award. The $595,000 grant will support Li's innovative research focused on the interactions between correlated electrons and phonons in complex quantum materials. His work addresses a significant challenge in condensed matter physics, deciphering how these interactions give rise to exotic quantum states that could revolutionize technologies such as transistors and solar cells. Li's research utilizes first principles methods, which rely on fundamental quantum mechanical laws without adjustable parameters, to explore the behaviors of materials with Kagome lattice structures and beyond. This award not only emphasizes Li's potential as a leader in both research and education, but also aims to inspire the next generation of materials scientists through educational initiatives like summer internships and tailored training for graduate researchers. In another noteworthy development, researchers are on the cusp of detecting anyon's exotic quasiparticles that could play a crucial role in the realm of quantum computing in one-dimensional quantum systems. This work is pivotal for advancing fault-tolerant quantum technologies, as anyons exhibit non-abelian statistics and are theorized to be instrumental in the construction of topological qubits. As the field of quantum materials continues to evolve, the intersection of superconductivity, magnetism, and quantum computing appears increasingly promising. The discoveries made at MIT and USC highlight a vibrant landscape of research that not only expands our theoretical understanding but also paves the way for practical applications that could redefine technology in the coming decades. With ongoing investigations and the potential for transformative breakthroughs, the future of quantum technologies looks brighter than ever.